Yes. Uh, Today we will give the introduction to differential equations. It's okay. And here, first of all, let's give an equation and in this form. And here f and the capital F T y prime y to the nth derivative of y is equal 0. This one is the equation, but in the look at this equation. This equation contains y prime, and y double prime, and the nth derivative of the y. And here y is a function, t a variable. So y is y of t. Y is a dependent variable, t independent variable. It's okay. And here n natural number here is okay. N and t independent variable, yes. Sometimes and we can use the x, it's okay, instead of the t, and the y is y of x is the independent variable, it's okay, and y is the dependent variable, it's okay, and is called as a function. And this and the equation contains this function and all derivatives, some derivatives of the y with respect to t, if t is the independent variable or x. It's okay. And this and the function, this equation called ordinary differential equation. Ordinary differential equation, and we can write and this one and this one is called the ODE. It's okay. So, but order here n. What does it mean order n? And means the order of the differential equation is the order of the highest derivative. And look at this one, highest derivative this one. So this one gives this n is the order of this differential equation. It's okay. Highest derivative is okay. So let's give example. For example, look at this one. It's okay. This one contains y prime, y double prime, and this one. So, and the highest derivative this one, and so our differential equation, third order differential equation for y is y of t, because and the t here and the t, and then t independent variable. It's okay. Y is a function of t. And the second one, this one, the partial and these and the equation contains partial derivative, and not, and this one is d over dx. It's okay, derivative or derivative of the with respect to x, but and this one partial derivative. It's okay, partial derivative, curly d goes and this one. So, and means our function and the y here, y depends on only one variable, x, for example. It's okay, because dy over dx. But here, write y and or u, it's okay, and means u is a function of x and another variable, for example, t. It's okay. We have two independent variable here because we can mention the partial derivative. It's okay, partial derivatives. So, and here, an ordinary differential equation is okay. Take ordinary differential equation of order n. It's okay. Highest derivative n. The nth derivative is okay. So, and the ordinary differential equation of order n is called the linear. If our equation it is equation is of this form. What's the form? And this equation, look at this equation, and the nth derivative and n minus 1 derivative of the y and y, and but look at the coefficient of and the derivatives, and use a different color, and this one, and this one, and also look at the right hand side. All of them are function of t, not contains y double prime, y prime, or so on. It's okay, and it contains only t, and the coefficients are functions of t only. And so if our equation in this form, and we can say that our equation is a linear. Otherwise, it's called to non-linear. It's okay, non-linear. So, for example, look at this one. It's okay. This one, third order differential equation, is a linear or not? Not linear because look at the coefficient of y prime contains y. Not linear. It's okay. This one. And also our equation, this one is a linear or not, but ordinary differential equation should be ordinary differential equation, not partial differential equation. This one is the partial differential equation. It's okay. So, and for example, look at this one. This one is okay. Contains y double prime, y prime, and y. Look at the coefficients t squared, t3, and the right hand side sine t are function of t. So this one is a linear equation. Look at the next one. Next one contains y prime, y, and the y cube. What's the y cube? Y cube means and the y squared times y. The coefficient of y and t times y squared. So non-linear. It's okay. Non-linear. And here our aim is to get the solution of our equation. It's okay. Our equation, of course, our equation here contains derivatives, so our equation is differential equation because contain our function y and also derivatives also of the y and also here. So this equation is called the differential equation. It's okay. So our aim is to solve this differential equation. It's okay. So, and the question, what's the solution? Solution and solution means solution of the solution of the y to the n and this one. Because look at this one, f of t, y prime and y. The n derivative is 0. So solve for and this one and for the n derivative of y, so we obtain this one. It's okay here. So solution of the and this equation means a solution of this one. It's okay. On the interval and the t between a and b. It's okay. So what is this one? What's the solution? Solution is a function. Okay, solution is a function. This function, for example, f of t, not f of phi of t, is okay, such that differentiable under this function and of order n, and also and substitute here, and satisfy. It's okay, and right y is sorry. And they substitute this on y phi of t and here and satisfy. So and the nth derivative of the phi of t and right y is phi of t, y prime is phi prime t, and so on. And for all and t in this interval. It's okay. Solution means and they satisfy our equation. It's okay, our equation. So our aim is to find the solution and means find the such function. It's okay, phi of t. So let's give an example to understand this concept. It's okay. So first example, phi of t c times e t for any constant c. We claim that this function is a solution of our equation, this one. So let's check then this one. We claim that this one is a solution of differential equation and means and this and the phi of t satisfy this equation. Let's see that. For example, and the right is this one is y. It's okay. So compute and look at our differential y prime. Y prime is yes c e to the t. Y double prime is c e to the t. So right here, it's okay. Our aim is to check that y minus y is 0, substitute y is phi of t, and this one, y, and the c e to the t minus c e to the t, and this one is 0. Yes, 0 is equal 0. So means, yes, y is c e to the t is a solution of our differential equation. It's okay? Any question? No, okay. So, next one, for example, and the C is a constant here, it's okay. C is a constant. For example, take the C is, and what does it mean? And this one is the solution of this equation. C is a constant. So means, and the C, any constant means take the C is 2. And also we obtain this one. This one is a solution. And also take, for example, C is 100 e to the t. And also this one is another solution. We get infinitely many solutions of our differential equation. It's okay. And the next one, for example, take C is 2. C is 2. It's okay. And this one is the only solution of the initial value problem. Initial value problem is denoted by IVP. It's okay. Is the and the first letter is the capital letter. It's okay. This one is the initial value problem. Initial value problem. Initial value problem means, and this problem contains one equation. It's okay. And also one initial condition. It's okay, initial condition. This one is a differential equation, and this one is called the initial condition. And means and a solution of the initial value problem means and it satisfy this equation and also satisfy the initial condition. It's okay. First of all, and we know that this one is the solution of this equation, and check that and this condition and our solution satisfy our initial condition. Y0 should be 2, and check that and write here y of 0. Our aim is to check that and the y0 is 2, and here if y is this one. It's okay. 2 times e to the 0, 2 times 1 is 2. Yes, satisfy the initial condition. So, and means, yes, our claim is true. Y 2 times e to the 2 is the solution of the initial value problem. And this one is the unique solution. It's okay. If our differential equation this one, we get the solution and the general solution means and it contains the and the constant and C arbitrary real number, for example. So we get infinitely many solution, and this one gives the general solution. But and take this equation and also take the initial condition. So we have, for example, take and this one we have infinitely many solution here. It's okay. For example, take the C and is 1 e to the t. Take the C is 2 times e to the t, another solution, and take 100 e to the t, another solution. We get infinitely many solutions, but our aim is to find only one solution such that y0 is 2 and this one. We obtain only one solution. It's okay, only one solution. It's the unique solution of the initial value problem. It's okay. And so the graph of the graphs of the C, y is C e to the t. It's okay here. And this one is the C is a constant. So look at the graphs of the y C e to the t. And for example, take C is 1 e to the t, another one 2 e to the t. So 100 e to the 2 e to, or minus C any constants minus e to the t, and so on. So and look at the graphs of these functions. It's okay. And these graphs are called the integral curves. Integral curves. It's okay. And now let's give the definition of the first order equation. What's the first order equation? And these equations is in these equations are in this form. What's the form? First order, and means highest derivative should be first order derivative. It's okay. dy over dt, and also is equal, and the right side is a function of t and y. It's okay. Right hand side f of ty. It's okay. And if our equation in this form and is called the first order differential equation because highest order is the first order. It's okay. So, or equivalently, and this and the equation can be written in this form. It's okay. This form. What's the form? And this one. This one and this one. Because and the solve for, and here, look at the second one. Solve for dy over dt, and we obtain dy over dt minus mty over nty. And this one is denoted by f of ty. It's the same. It's okay. The same. So, and our equation is called the differential equation is called the first order equation. It's okay. So, and then now let's consider the first order equations, and then our aim is to solve the first order differential equations. It's okay. The first method is okay, and take our differential equation, this one, or take this form, and check that, and our equation is a linear or not. If our equation is linear, and what does it mean? And linear means and it contains and the first order y prime and the y, and look at the coefficients of y prime, and this one is 1, this one is p of t, and the right hand side g of t. So this one is a linear because and the coefficients are functions of t. It's okay, linear. So and this equation, first order linear equation. So question and rewrite and this one dy over dt, and this one here write this one is y. It's okay, p of ty, and this one is denoted by y prime and this form. So and the coefficient of y is denoted by p of t, and the right hand side is denoted by g of t. So our aim here, and the first and the step, and always first step, identify the R differential equation, and then the second step, choose the appropriate and the method, and then solve this and the equation. It's okay. Now and look at this equation, and this equation first order linear equation. So and the next step, how to solve these differential equations. So and find the y, and such that y satisfies this equation. It's okay. So here consider a function nu, and the nu is a function nu of t, and the variable and here and the dy over dt, and means y depends on t. It's okay. Independent variable t here. And the consider mu is okay, differentiable, and such that satisfy this one. What does it mean under this one? It's okay. And look at our differential equation. Look at the right hand side, left side. Sorry, left side. What's the left side? Left side, this one. It's okay. And consider a function such that d over dt nu of y. Nu of y should be and the nu times this one, nu times this one. It's okay. And here our aim is to solve this differential equation, find the y. It's okay. Find y. It's okay. And so here take the nu differentiable such that this one, this mu, this function is a special function. Look at the right left side of our differential equation. Nu times left side should be this one. It's okay. Now let's find and mu here. It's okay, mu, and look at this one. It's okay. What does it mean, this one? This one is the product rule, derivative of the product. What's the derivative of the product? We know that, and the u, v, and the prime. What's the and this one? We know, and from calculus, and the u prime times v plus u times v prime. It's okay, product rule. And here product mu times y, mu y dy over dt, and means derivative with respect to t. It's okay, this one. So derivative of the first one, d nu over dt times y plus first one times derivative of the second one, dy over dt. It's okay? So look at this one, and left side is equal this one. But our mu, special mu, and satisfy this equation, and compare the left side this one. So compare this one and this one. Mu dy over dt, this one. And so this part should be py. Our aim is to find the mu such that special and the mu and satisfy this equation. So, and py should be this one. It's okay? So means, yes, and ignore and this one, mu over t, and it should be, but here be careful, mu times this one should be. And d mu over dt should be mu py. And so, and this one, so mu prime should be mu p. It's okay? So we obtain this equation, the next one. So we obtain, and the mu prime is mu times p. So our aim is to get this and the mu. And what is the mu? How to get? Integrating both sides. So we obtain mu. It's okay? But and here, and first, and the rewrite, and then integrating, sorry. And this one is, yes, mu prime over mu is p. Integrating both sides with respect to t, and then we obtain this one. This one is equal ln mu. This one is this part. It's okay? This part. So, and here assume and the mu and positive is okay, is greater than 0, greater than 0. And so, and solve for mu. Our aim is to find the differentiable mu function. So mu is e to the, mu is, yes, and look at this one, mu is e to the integral p dt. It's okay? And this mu is called the integrating factor of and the equation. It's okay? We claim that by using this mu and this integrating and the factor, and the multiply and the both sides of and our equation, and then we obtain the solution. It's okay? Solution. So, and multiply mu here. It's okay? Multiply mu and this one and this one. So, and we know that, and this one is equal this one, because mu satisfies this equation, this one. So left side of our differential equation, this one. So means, and what does it mean? And we can say that this one should be this one. It's okay. Right here, d over dt mu y should be right hand side, mu times g of t, mu times g of t. So, and our aim is to solve the, and therefore, and the y, our aim is to get y. And so, how to get y? And integrating both sides. And so, rewrite, and this one, dt, integrating both sides. So, and cancel this one and this one, mu y is equal this integral. Our aim is to get y, and solve for y here. We obtain 1 over nu times integral. It's okay? And the c, of course, c is a constant of integration, constant. It's okay? Here. So we obtain the solution. What's the solution? And the y, if our equation is a linear equation, it's okay, first order linear equation, by using the mu and multiply both sides of our differential equation, and then integrating both sides, and we obtain our solution. It's okay, our solution. Any question here? We claim that, and find the mu mu is depends on p, and the p is the coefficient of y, and then multiply mu both sides. It's okay, this one. So solve for, and also we know that this part is d nu y over dt, and so we obtain this one, and integrating both sides and solve for y is 1 over nu, and the integral and this one. It's okay. So we obtain our solution of the differential equation. Okay. Now let's give an example to understand this method. It's okay. How to apply. For example, look at we have some example here. It's okay. And let's take the first example, this one, and solve this differential equation, and the answer here. It's okay. And so let's take this one. So first of all, identify this differential equation. It's okay. What can say about this differential equation? Look at the highest and the derivative, and it contains y and y prime. So first order differential equation, and linear. Yes, linear, because look at the coefficient of y prime is a function of t. Coefficient of y is a function of t. Right hand side is a function of t. So this one is a linear. First order linear differential equation. So we know how to solve this equation, this type, because using then the mu integrating factor and multiply by nu and solve for y. So what's the y? And but be careful, and here be careful. Look at this one. Our differential equation in this form. What is the form? And the y here. The y prime, coefficient y prime should be 1. Be careful. Be careful. And the nu here, and this one, and what is the p here? P coefficient of y, and this one, but the coefficient of y prime should be 1. Should be standard form. This form is called the standard form. Let's come back here. But this one is not standard form, and this coefficient should be 1. Be careful. So P of t, not this one. It's okay. So, and the standard form, what's the standard form? Y prime, and divide 1 over 4 plus t square. So we obtain 2t plus 4 plus t square y, 4t over 4 plus t square. Yes, this one is the standard form of our equation, because coefficient of y prime is 1 here. It's okay. So what's the P of t? Yes, P of t, this one. And the G of the right hand side, this one. It's okay. Be careful. And but stop here, and let's give the different method and solve this one. It's okay. And look at this one. How to solve? If we don't know this method and this and the integrating and the factor, and have to find this and the factor. It's okay. So take this one. Our aim is to solve this one. It's okay. And yes, look at the left side. Be careful, left side. Look at the left side. Left side, we claim that is equal and the derivative of this one. It is easy to see that because this one is the product, derivative of the product. uv prime, u times v plus u times v prime. Look at this one. And we claim that left side and this one is equal and the derivative of the product, because let's check that derivative of the first one 2 times t times second one plus first one times derivative of the second one, this one, and this one is equal to this one. Look at this one, the same. It's okay. So means, and the left side is equal to derivative of this product. So if we see that, so it is easy to see that if left side is the derivative of this one, and the right here, it's okay, in the equation, this one is equal. So we obtain this one is equal for t. It's okay, this one. Any question? This one it is important in this step. It's okay. If you see that, you can see that, and the left side is the derivative of this one, and so substitute here, and this one is equal for t. It's okay. This one. So, and it is easy to solve for y because integrating both sides is okay. This one is rewrite, and this one is d over this one dt. This one we obtain. Integrating both sides, this one cancel this one. So we obtain left side this one, and the right side integral for t dt. And so, and what's the end of this integral? For t square over 2, we obtain this one. So, and our aim is solve for y here, solve for y, and y is equal, yes, to t square over 4t square plus c over this one. Yes, we obtain and the solution. Any question? Any question? Okay, I hope no question. Okay, everything is clear. So, but, and don't use and this one. Maybe and we don't know and this one. It's okay. Cannot see and this one. Maybe it's okay. May or may not, of course. And use the and this method. Which method? And this one. Use the integrating factor. It's okay. So first of all, write the standard form of our equation and this one. It's okay. This one. It's okay. Let's use this method for the same equation. It's okay. Our equation, right? First of all, you have to write our equation in the standard form. Standard form means the coefficient of y prime should be 1. So, and determine and the p of t. What's the p of t? Coefficient of y, and the right hand side g of t. Yes, this one and this one. So what's the nu? Nu is, we know that mu is e to the p of t dt. P if this one. Yes. So what is the this one? And this integral we know from calculus, and this one is u. This one is u prime. And u over u prime over u integral du, and this one is ln u. It's okay, ln u, absolute value ln u. But here u4 plus t square is the positive, no absolute value. It's okay. And so, and we know that, and also e to the ln a, always a. It's okay, this one. So, and this one is equal a, 4 plus t square. So we obtain mu. What's the mu? Mu is 4 plus t square. It's okay, t square. And then our aim is to get the solve for y, and it's okay how to get and the y, and we know the and use the and the method and the multiply by nu, and then integrating both sides, or and we know the formula at the beginning. Nu is y is equal 1 over nu integral mu times g of t dt plus c. And right here, mu is this one, and mu times right hand side, g of t this one, substitute here plus c, and cancel, we obtain this integral. What's this integral? This integral gives this one, 2t square, multiply by this one, we obtain this one, and multiply by this one, we obtain this one. We obtain the same result. Why is this one? It's okay. Any question? But be careful, critical point, our equation should be linear equation, first order linear equation, and also should be in standard form, means coefficient of y prime should be 1. It's okay, this one should be 1. Okay. And now, Let's come back our examples. And for example, find the general solution of this differential equation. It's okay. This differential equation. Sorry. And first of all, identify this differential equation. This one is first order differential equation. Yes. This one is the linear. Yes. The coefficient of y prime, coefficient of y, and right hand side are function of t. It's okay. So this one is the first order linear differential equation. So yes, we can use then the integrating factor mu. Mu is e to the p dt. And also this one is the standard form because coefficient of y prime is 1. Yes. So, and then what's the p of t? P of t 1 over 2. 1 over 2 dt. And we obtain 1 over 2 t. It's okay? This one. So, and the mu is this one. So, what's the y? And the formula here, substitute mu. And then right hand side this one. And also this one. Substitute here. And we obtain this integral. So it is easy to see that this integral is equal this one. It's okay. So we obtain our solution. It's okay. Any question about this solution? I think it is clear. Now let's consider the next one. Next one, this one. Find the general solution of this differential equation. This differential equation, this one. And first order linear differential equation. Linear differential equation. And so standard form, yes, standard form. What's the p of t? Minus 2. Right here, minus 2. We obtain this one. And the substitute, and y is this one. It's okay. Y is this one, and we obtain this integral. G of t is 4 minus t. So we obtain this integral. And you have to know and you have to take the integral of this one. It's okay from calculus. This one is e to the minus t times and this one is a polynomial and exponential function product of these and the functions. So you have to use the integration by parts. What's the integration part by parts? U times dv integral u times v minus v times du. It's okay. So and look at this one. This one is equal. This integral is equal. This one. Take this one. Is integral and the 4 e to the minus 2t dt and the minus t e to the minus 2t dt. And look at this one. It's okay. And use the integration by parts only this part. Because we know this integral. It's okay. It is easy to see that. And use the integration by parts, the second and the part is this one. It's okay. So take this one, use the integration by parts. So we obtain under this one. So we obtain our solution. So and they substitute here 1 over this one, multiply the r, and this one is I. This one is I. It's okay. And the r y is this one times I plus this one. It's okay. So and they substitute and then we obtain our solution. It's okay. Yes. Any question about today's solution? Okay. So, and the next, let's look at the next example. What's the next example? This one. Solve the initial value problem. Solve the initial value problem. Ty prime plus 2y t 4t square and y of 1 is 2. Initial value problem, this problem, and means look at the previous example. The previous example solution y is equal to this one contains the constant c, this one. And also look at the previous one and find the general solution contains c. And so this one is the general solution. General solution means and this solution and it gives the infinitely many solution of and the how to check that any y is the solution and if we have the c value, for example 100, and so right here we obtain the y is 3 over 5, this one plus 100 e to the minus t over, yes, this one is the solution because and here c is 100, it's okay. So this one gives infinitely many solution. General solution means produce the and every solution of the and this differential equation. But here and let's come back our here the problem here and solve the initial value problem. Solve initial value problem. This one is initial value problem because contains one differential equation, one initial condition. But here, first order differential equation. First order differential equation to solve the unique solution of this differential equation, and if this one is initial value problem, contains one initial condition because order first. If and for example, second order differential equation and our equation. If this one is initial value problem, second order means you have the and the two initial conditions should be. But here, first order differential equation, initial value problem, if this one is initial value problem, we have only one initial condition. Is it okay? So, and the initial value problem always has unique solution. Find the unique solution of this initial value problem. But and the identify and the first this differential equation contains highest derivative is 1 and the first derivative. So first order differential equation and also look at the coefficient of y prime y and right hand side is a linear first order differential equation. But be careful, not standard form. And first of all, write the standard form. It's okay. Coefficient should be 1 here. Yes. So we obtain P of t and G of t. Let's stop here. Let's have a break, and then we will solve and this one. It's okay. Any question about the previous and the problem or subject? About any question? No question? Okay, let's have a break.